Slack?
Yep.
Okay. So you got the link on Zoom?
Yep.
You see that, Colin?
All right, so let's continue our talk about lists. Close that so I don't get pop-ups. All right, so I'm going to introduce a, well, at the end of class last time we talked about when you pass lists to functions, they're actually passed by reference. So any changes we make to that list inside of that function will be permanent, as opposed to if we pass like an integer to a function and we make a change to it, that change is only noticeable inside of the function. So I want to introduce one more thing today that is going to help us test some list stuff. So it's often handy to be able to generate random numbers in a certain range in any programming language. So in Python, we have a library called random. And the way we get access to that, at the top of our program, we say from random, it's all lowercase. Let's see if I can get it from, say something like that, from random import star. So what we're really saying is from the random library, give me everything. If we only need one or two things, you might just import those one or two things. But for convenience, we're just going to import everything. And the function, say this again. What was the question? All right, so yeah, if you want, so you can talk to people around you, just mute your mic, and then if you have a question, just unmute it to ask the question. All right, so the function we're actually going to use is called Rand Int, and this is low to high. I'm actually going to say low inclusive to high inclusive, because it does actually include that high number. So for instance, Rand Int 1 to 10 would give us a random number between 1 and 10 inclusive. Something along those lines. So let's go ahead and look at this and then write some manipulation functions on lists. So up top here we have our from random import star, and just as a quick little sample here, I'll just say for I in range 0 to 10, so we'll just do this 10 times. We'll go ahead and print out Rand Int 1 to 10. So this should give us 10 random numbers. So there's 10 numbers between 1 and 10. If I run it again, see we do get 10s and we do get 1s. So it's inclusive of those values. All right, so this is a little tool that allows us to get random numbers. If I want to make it a bigger random number, I can say 1 to 1,000. And now I get larger numbers. All right, so questions about the Rand Int function?
No, that makes sense.
Just a little convenience for us to be able to get random integers. So what we want to go ahead and do is we'll write a little function. So we'll define a function called fill list with randoms. And this guy will take in a list as a parameter. And number of randoms, since we'll assume they're going to send us in an empty list that we'll then fill up. So we'll go ahead and say for I in range 0 to number of randoms. So we're going to do something this many times. What are we going to do? We're going to append onto this list a random number. So list.append Rand Int, and we'll just do 1 to 1,000 for the sake of our example here. All right, so we wrote a little ability called fill list with randoms that we can pass a list to and tell it the number of random numbers we want to have in that list. And it will go ahead and it will append to that list that number of random integers. Now, we're presuming this list is passed in as the empty list, but if it's not, it'll just tack on to the end of it this many random integers between 1 and 1,000. So let's see this here. So out here, outside of my functions, I'll go ahead and I'll create a my list. I'll start that guy off as the empty list. I'll go ahead and print my list, which should print nothing. Here's my empty list. Then I'll call fill list with randoms. I'll pass it my list, and let's go ahead and fill it with 100 random numbers. And then I'll print my list. This is my list before I passed it to that function. This is my list after I passed it to that function. So again, this is an example of pass by reference. This list was created out here in the global scope. I printed it out. We saw that it was empty. I then passed my list into this function up here. It came into this function up here under a variable called LST. And what did we do inside of this function? We appended a bunch of values onto the end of LST. By us doing that inside of this function, it had a permanent change, a permanent impact on my list. And we proved that by after this function was finished, when it ended, after this line, we went and printed out my list and saw that my list now has a bunch of stuff in it. Now let me just show you the alternative to that. Let's say def add to string randoms. This will take a string as a parameter and a number of randoms. And I say for I in range 0 to number of randoms, S is equal to S concatenated with the string version of Rand Int 1 to 1,000. So I'll go ahead and generate my random integer. Then I'll convert it to a string, which will then allow me to concatenate it onto my current string. So then out here, I can create the empty string. I can say print, well here, I'll call this guy my string just so there's a little bit completely different. I'll print out my string. Then I'll call add to string randoms. I'll pass it my string. I'll pass it 100. And I'll print my string. Here's my string the first time. Here's my string the second time. Both of them are the empty string. You want to prove that to yourself. Here, I'll just throw an LOL inside of my string with the hope that we'll concatenate on 100 random numbers after LOL. And we see we get LOL twice here. So that tells us, and just to prove, if I go inside of my function here and I say print S after that loop, we'll see that that string that started off as LOL did in fact get 100 random numbers tacked onto the end of it. So there's my LOL with crazy stuff tacked onto the end of it. So this is before the call to the function. This is inside the function. This is after the call to the function. We see that my string did not have a permanent change. That means that that guy was passed by value. We gave it a copy of my string, and we were operating on that copy inside the function. So inside here, we did make changes to S. We clearly saw that. This is definitely a modification of my string. But after this function ended, those changes were not preserved because that function was working with a copy of my string as opposed to the real memory address where it lived. That's different than what we experienced up here with our list, where we started off with an empty list. If I want to prove it to you, I'll just go ahead and I'll print out my list in here. So we start off with the empty list. Here's me printing out the list inside the function. And then here's me printing out the list after the function ended, proving that that list was permanently altered. As opposed to when we use strings or integers or any of our primitive types. Here's my string before the function. Here's my string inside the function after I made changes to it. But here's my string after the function. We see that any of those changes have been lost because the function was working with a copy of the string, not the original. That makes sense? The difference between pass by value and pass by reference. Okay. So, really important concept when you're dealing with lists. Now, let's say that I wanted to shuffle my list of numbers. All right, so when I say shuffle, go ahead and take this, well here, just for the sake of, I'm going to give you this current code in Slack as an example of pass by number versus pass by reference, since it's all kind of self-contained here. Okay. So then I can gut some of this stuff. I'm going to get rid of the string stuff right now since I want to keep messing with lists. Okay, so right now we have filled this list up with random values. Now, let's actually say that we want to be a little bit more specific. Let's say we were dealing with like a deck of cards. Okay, if we have a deck of cards, we have 4 different suits, and we have a bunch of numbers inside of those suits, right? So we can say def get deck of cards. Oh, wrong language. So we can have a function that gives us a fresh deck of cards. So instead of me passing this guy a list, I'm just going to ask him to give me a list. And I want that list to be a fresh deck of cards. Now, for the time being, what we're going to do is we're going to forget that suits exist. So we're just going to say that in that deck of cards, there's going to be 4 2s, 4 3s, 4 4s, 4 jacks, 4 queens, 4 kings, 4 aces, something like that. If you want to throw jokers in there, we can. All right, so I'll go ahead and I'm going to create a little string called card vals and hold all of the individual values of our deck of cards. So we have a little bit of an issue here. So I have 2, 3, 4, 5, 6, 7, 8, 9. Now technically 10s live in there. Okay. Then we have Jack, Queen, King, Ace, and if you want to put jokers in there, that'll confuse the Jack, but that's fine. We can just say Joker. That's just as bad as our 10. So we have 2 guys here that are kind of left in the left out, correct? Now, what we'd like to do is walk through here and say, I want to get 4 of these, 4 of these, 4 of these, 4 of these, so on and so forth. So for right now, I'm going to get rid of the 10. I'm going to get rid of the joker, and let's just solve it the clean way. And then we'll figure out how can we fix this. So I'm going to give myself almost a deck of cards. That is, I want 4 of each of these values inside of my deck. So I'm going to start my deck off as the empty deck. There's no cards in my deck, so we can think of this as kind of like the manufacturing plant that's creating decks of cards. And I'm going to say for I in range of from 0 to the length of card vals. I'm going to go through every single char that's inside of this string. And each time through, I want to append that guy to this deck 4 times. So deck.append card vals at bucket I. And I'll do that 4 times. When all is said and done, I'll return deck. So this is like us going to the store, asking for a deck of cards, them running into the back, building us a deck of cards, not a very good one in this case, has no suits and is missing some cards, and then handing us back. We'll say my deck is equal to get deck of cards. And then we can go ahead and print out my deck. So we're going to ask this factory to give us a deck of cards, and then we'll prove that we got that deck of cards. So there's my deck of cards with 4 2s, 4 3s, 4 4s, so on and so forth. That makes sense? Mm-hmm. But now, I really, really, really want to be able to have 10s in there and jokers in there. I'm less concerned about the jokers, but I'd like to have the 10s. In fact, I'm just leave the jokers off. I like to get 10s in there. So if I leave it like this, if I don't change my code at all, and I go ahead and run this, it's not going to crash. I'm just going to get 4 more 1s. Well, I'm going to get 4 1s and 4 zeros. There's my 4 1s. There's my 4 zeros. I didn't get 10s. I got 4 of the first digit and 4 of the second digit. All right, so I actually want all of them. So what if I decided to organize my string like this? So now we've kind of formatted this where it's a little bit clearer that I want this entire chunk here, right? But now if I walk through that guy one element at a time, like I am here, I'm going to get a whole bunch of commas and stuff. So if I don't change anything, let's go to run this, I get cards that just have commas on it. And we just know the guy's cheating then, right? All right, so that's not what we want. But maybe this is the first step towards what we want. What if I said we needed to write a function that took a string as a parameter, maybe it's a comma delimited string. Here we'll spell it out, split, comma, delim string to list. So it took something like this, and it turned it into a list where the first element was a 2, the second element was a 3, so on and so forth. The next element was a 10. So now what we're going to do is we need to walk through this list looking for commas. And every single time we find a comma, we know that we have finished one of our numbers. This is kind of similar to the logic we worked with when we were doing our process expression, doing adding and subtracting of those numbers. All right, so I know I'm going to go through every element in my string. But each time through, I'm going to be collecting a current string. And then I need to have my list that I'm collecting them in. So what I want to do is, as I go through here, I want to collect everything up to the first comma. So if S at bucket I is not equal to a comma, we'll just be explicit. If I'm not looking at a comma, I want to collect it. So I'll say current string is equal to current string concatenated with S at bucket I. So I'll capture this too. Otherwise, I am looking at a comma. And if I am looking at a comma, what do I want to do with my current string? My current string is built up with a 2. And what do I want to do with that guy? I want to append it to the end of list. Then I can zero out current string and start over. So I'll collect the 2, I hit the comma, I add the 2 to my list, I zero it out, move on. Collect the 3, hit the comma, add the 3 to my list, zero it out, move on. Collect the 4, so on and so forth. Collect the 1, collect the 0, so now I have the whole 10. Hit the comma, add 10 to my list, zero it out, move on, so on and so forth. Now when I get to the very end of this guy, I'm going to have one last value stuck inside of current string. Because I collected this A, but I never hit a comma. So what am I going to do with that? I'm just going to do one last list.append current string. And then I'll return that list. So this guy right here is a little tool that I can pass a string like this to, and it will give me back the list version of this that takes care of the 10. And if I really wanted to have a joker on there, I could. So now what I'll say here is I'll say split comma delimited strings to list. Well, here, let me just do it in 2 pieces here. I'll copy this. I'll go ahead and split comma delimited strings to list like this. So I'm going to pass in this guy and ask him to split it into a list. And then we'll see that we get a list that has a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, J, Q, K, A, and joker. Where is it screaming at it? Line 11. Oh, I just put S. This is the length of S. So there's our 2, 3, 4, 5, 6, 7, 8, 9. There's our entire 10. Jack, Queen, King, Ace, Joker. All right, so we were able to, by putting our string in a format that was understandable by us, we can then write a custom function that will go through and separate that into its pieces. Now, we could have split this by anything. We didn't have to do commas. We could have done smiley faces or something like that. But commas makes a lot of sense, and if you've ever seen Excel documents, you can export them to CSV files, comma-separated value files. So this is a fairly common output type. All right, so now what I can do is I can steal this guy. And I can say my card vals is equal to the list version of these guys all split up. Then I can go through and append onto my deck each of those card vals 4 times. And then return my deck. So there's my deck of cards. 4 10s and 4 jokers. All right, so now what if? So any questions on that before I keep trucking?
I think so. That makes sense. Oh.
So what if we wanted to shuffle our deck of cards? That's what they do at the casino, right? They sit there and they shuffle it up. What does it mean to shuffle a deck of cards? So our deck right now is a list of 50-some cards. 56 cards with the jokers. So what does it mean to shuffle that deck?
To shuffle a deck is to reorder the numbers based off of random.
Okay. Do we have the ability to do anything randomly right now?
Sort of.
Okay. So do you have a suggestion on how we might shuffle this deck?
No, I can't think of it right now.
So if I went through, I have my 56 cards sitting in front of me, and I picked one of the cards, and I picked another card, and I just swapped their positions. And I did that like 1,000 times. Would that shuffle the deck?
Yeah.
I mean, it'd be a little creepy to see somebody at a casino go through and do that one card at a time. Instead, they do the flashy, shuffle thing. And but really, what you're doing is you're swapping places of cards over and over and over again, right? So if I'm inside shuffle deck here, I have how many cards do I have inside of shuffle deck? I have length of deck, number of cards, correct? And the first card in there is at bucket 0. And the last card in there is at bucket length of deck -1. So I need to generate 2 numbers for the 2 cards I want to swap. I need to generate a number for card 1. I need to generate a number for card 2. Both of those numbers need to be between 0 and length of deck -1. Then I need to swap the card. So let's say that I'm going to do that 1,000 times. So we'll say 1,000 times I'm going to pick 2 cards out of the deck and have them switch places. So we'll say card pause 1 is equal to, now I need to generate a random number between 0 and the length of deck -1. So Rand Int 0, length of deck -1. That'll give me 1 number. Card pause 2 is Rand Int 0, length of deck -1. That'll give me another number. So now I have 2 positions in the deck. The position of the card at card pause 1 and the position of the card at card pause 2. So I'm going to say temp card is equal to deck at bucket card pause 1. So I'll temporarily hold on to that card. Then I'll say deck at position card pause 1 will get overwritten with deck at position card pause 2. So after I preserve card pause 1, I can then overwrite him with card pause 2. Then I'll overwrite card pause 2 with what I had preserved inside of temp. Okay? And I'm going to do that 1,000 times. So 1,000 times I'm going to randomly select 2 locations in the deck, and then I'm going to swap those 2 locations. And because lists are passed by reference, I don't have to return anything. This should give me a shuffled deck. So here's my unshuffled deck. And I'll say shuffle deck. I'll pass it the deck. Then I'll print. I'm sorry, I got to pass it my deck. Then I'll print out my deck, which should be shuffled. Called it temp card, not temp. So here's our unshuffled deck, and here is our shuffled deck. And you could have picked something more or less than 1,000 if you thought you needed to do that more or less times in order to get a properly shuffled deck. There's a interesting, it's almost like a Rubik's Cube type problem with something like this. Where how many times do you have to shuffle the deck until it's back in its original configuration? Just by sheer randomness. Now we got 56 cards, and we keep swapping 2 over and over and over again. How many billions of times do we need to do that before we've accidentally put the thing right back in the position it was originally in? It's an interesting statistics simulation. The answer is, well, technically with really bad luck, we could do it just one time, but the point is that it should eventually happen. Randomly, it should eventually get back into its original position. All right, so now we have shuffled this deck of cards. All right. Now I want to show you something here that the book does introduce. I think it is. I think it's that. So notice here that here's a string, and here's the function we did not write called split. So there already exists a function that effectively does what we wrote up here. This split comma delimited string to list. So there's one that already is built into it for allowing us to solve that problem more quickly. So for us, this is okay to solve this. Although, hold on, I think this did not split it the way we want to split it. I think this split it, because this actually gave us a 1 list. Maybe split on spaces for that guy. Maybe it's. Yeah, there we go. So it almost works the same. Split by default will split a string up on spaces for you and give you a list representation of that. So if you knew about the existence of that tool, if you knew about the existence of the built-in split function, I'll go ahead and add it to our note. Strings have the ability to split themselves into lists by looking for space-based delimiters. For example, from that list. Notice, though, this is a list of characters, not a list of numbers. So you would need to convert them to numbers if you wanted to do math with them. But it is convenient to do things like we've had to do today. But we also hopefully saw that even if you don't know if something like that exists, writing a function to effectively do it isn't that bad. Now, I realize that for most of you, sitting down and just pumping this out real quick might take a little bit of effort, but hopefully you're at the point now where you've seen yourself improve a lot enough that you can view this and say, I think it's going to be within my wheelhouse eventually that I can just take 20 seconds of my life and write this real quick. And I don't have to worry whether or not this power tool exists or not. You do a quick Google search. If the first thing comes back, shows you that it's there, great, use it. If it doesn't, I mean, you can go on a wild goose chase, or you can just write it yourself and move on with life. So try to keep that in mind when you're writing code moving forward. Don't spend too much time searching for the perfect solution to the exact weird problem you're trying to solve that may or may not be built into the language. Chances are, if your problem is weird enough, it's not built into the language. But there's also a pretty good chance that you might spend more time searching than you would have just spent writing it if you just started and just wrote the quick little function to do what you needed. All right. So this is our deck of cards that's now shuffled. So now we want to have the ability to deal let's see, what a blackjack hand. Now a hand in blackjack is 2 cards, right? So, then potentially additional cards. Now, we saw last time in the book that we have a remove function. It was like removing index or something like that. Chapter 8. Yeah, we can use pop. Pop will let us do it. Remove and return the last item in the list. So we can think about popping a card from the deck, and that will give us a card. So let's say def deal card from a deck. And this guy will return deck.pop. So that will return the very top card from the deck, but it will also permanently change deck because lists are passed by address, passed by reference. So by me removing something from the top means it has now been removed from that list permanently, but I'm going to return it for whoever asked for this. Deal a blackjack hand. We're going to say a hand is equal to an empty list. So when you first sit down at the blackjack table, you have no cards in your hand. Then we'll say deal card. Sorry, we'll say hand dot append deal card hand dot append deal card. Then we'll return hand. All right, so we wrote a function that just deals a single card. We wrote a function that deals a blackjack hand, which will give 2 cards to somebody. Now this kind of forgets about the thing where you deal 1 card to each person and stuff like that. We're dealing 2 cards at once, and forget about whether that's cheating or not. All right, so we'll get a deck of cards from the manufacturer. We'll shuffle it. We'll go ahead and get hand 1. The old blackjack hand. Pass it my deck. Hand 2. Deal a blackjack hand. Pass it my deck. Now, my deck should be smaller than it was before. There should be things that are missing from it. So I'm going to go ahead and print out hand 1. I'll print out hand 2. And I'll go ahead and print out my deck here at the end, just so we can see that the elements of hand 1 and hand 2 should no longer be found inside of my deck. Well, let me clear this first. Oh, hold on. I didn't have it take any parameters. Deal a blackjack hand has to take in a deck, and then we pass that deck on to deal a card. So deal a card needs a deck to work. Deal a blackjack hand needs a deck to work. So if I hand to the dealer the deck and say, deal me a blackjack hand, he's going to then hand it to himself to deal a single card, deal another single card, so on and so forth. So there's our first blackjack hand. Here's our second blackjack hand. Now here is our full list of cards, and we should notice that at least, at most we have, let's see, we should have 3 8s still in there. We should have 3 7s, 3 queens, and 3 6s. But we are missing some cards because we have removed these 4. Does that make sense? Now, we want a function called get value of blackjack hand. We want this guy to return a list of the possible values of the hand. Number cards have a value that is their number. Face cards like Jack, Queen, King. And just so I don't forget here, we're going to go ahead and take jokers out of our deck. Jokers aren't part of blackjack. So face cards, Jack, Queen, King, have a value of 10. Aces have a value of 1 or 11. So it is possible for a hand to have 2 values, or even more if there are more than 1 aces. More than 1 value. All right, so for homework, we're going to write this function called get value of blackjack hand that will take a hand in as a parameter. For example, if it was this hand right here, it should return a single list. So here, I'll copy this. Examples. It returns a list of 15. That's the only value that hand has. This guy would have a value of 16. Now I'm going to fake one here. This guy would have a value of 11 or 21. Because this 8 can either be a 1 or it can be an 11. So this is either a 10 plus a 1, which is an 11, or it's a 10 plus an 11, which is 21. So for homework, you're going to write this function based on all the other stuff I have written here. And I'll give you all this code in Slack as a starting point. All right, questions, what I'm asking you to do? I'll go ahead and copy all this. I'll paste it into Slack so you have it. Starting point for Blackjack homework. All right. So that's up there. I'll go ahead and post the assignment, and hopefully I will be back to civilization on Monday, but we'll see. I'm going to the doctor today at 1:30 since this thing doesn't seem to be going away. But worst case, we're going to meet one way or another, but I'm hoping I'm back in person on Monday. All right, so I'll go ahead and upload the video, and if you have any questions about any of the stuff from the homework or whatever, feel free to email me or catch me on Slack. I'm around. I'm just kind of sitting on the couch all day. I don't want to infect people around me. So feel free to ask me questions. I'm happy to help. All right, I will see everybody on Monday. All right, there, let me look at the chat just in case that was an important question. No. All right. I don't think so.